For most of history, we assumed our solar system was ordinary. One star, a few planets, nothing worth special attention. It felt safe to believe that our home was just one of countless, similar arrangements scattered across the universe. But that belief was never tested. It was simply assumed. Then we started finding other solar systems. What we discovered did not confirm our expectations. It shattered them. Planet after planet appeared in places they should not exist. Systems formed in ways our models could not explain. And as the data grew, one uncomfortable realization began to emerge. The place we call home does not look typical at all. It may be an exception. And if that is true, then the story of Earth, life, and our very existence becomes far more unlikely than we ever imagined. Body, what we found beyond our system. The first confirmed exoplanets were shocking not because they existed, but because of where they were located. Massive gas giants were found orbiting closer to their stars than Mercury orbits the Sun. These planets, some larger than Jupiter, completed full orbits in just a few days, exposed to extreme radiation and gravitational stress. According to older models, these planets should not have been there at all. As detection methods improved, the strangeness multiplied. Astronomers discovered solar systems where planets were packed so tightly together that multiple worlds orbited closer to one another than the distance between Earth and the Moon. Other systems showed planets tilted at extreme angles, orbiting sideways or even backward relative to their star's rotation. Some systems were chaotic, with unstable orbits that suggested violent pasts involving planetary collisions and ejections. The more systems we observed, the clearer the pattern became. Our solar system was not simply different. It was statistically unusual. Most planetary systems do not have wide, evenly spaced orbits. Most do not place their largest planets far from the star. Most do not maintain long-term stability over billions of years. And most importantly, many of them undergo violent migrations that completely reshape their inner regions. This brings us to one of the most critical features of our solar system, and perhaps the most overlooked reason it feels so calm: Jupiter and the survival of Earth. Jupiter is not merely a large planet drifting quietly at the edge of our solar system. It is a dominant gravitational architect, a force powerful enough to shape the fate of entire worlds. In many planetary systems across the galaxy, planets of similar size do not remain where they are. Born, they migrate, slowly at first, then relentlessly inward, driven by interactions with surrounding gas, dust, and neighboring planets. As they move, they tear through their systems, like wrecking balls, destabilizing orbits, ejecting smaller planets into deep space, and sending rocky worlds spiraling into their stars. Where these giants pass, inner solar systems are often left empty or scorched beyond recovery. In our solar system, something remarkable happened. Jupiter began this same inward journey, but then, for reasons that are still not fully understood, it stopped. Instead of plunging toward the Sun and erasing the inner planets, it settled into a distant, stable orbit. From that position, Jupiter became a gatekeeper. Its immense gravity intercepted countless asteroids and comets, either capturing them or redirecting them away from the fragile inner worlds. Without this intervention, Earth would have endured impacts so frequent and so violent that complex life may never have survived long enough to evolve. The precision of this outcome is unsettling. A slightly heavier Jupiter, a slightly different migration path, or a small shift in timing could have destabilized Earth's orbit or prevented the planet from forming at all. Computer simulations make this painfully clear. When scientists alter Jupiter's mass or orbital history by even small amounts, the inner solar system often collapses into chaos. Planets collide, are ejected, or are consumed by the Sun. This forces a difficult realization. If Jupiter-like planets typically migrate inward, and if ours did not, then the architecture that allowed Earth to exist may not be common. It may be the exception, a rare arrangement in which a giant planet paused at exactly the right moment, in exactly the right place, allowing a small, fragile world to survive long enough to question how unlikely its own existence truly is. Stability, time, and life. Life does not emerge simply because the ingredients are present. Chemistry alone is not enough. Life requires time, and not just time, but long stretches of uninterrupted calm, billions of years in which orbits remain steady. climates remain within narrow limits, and catastrophes remain rare enough to be survived. It requires a star that burns with restraint, not violence, and a planetary system that evolves gently, rather than tearing itself apart. Most known solar systems do not offer this kind of patience. Many stars are far more active than our Sun, releasing powerful flares that can strip atmospheres from nearby planets in a matter of centuries. Many planetary systems are dynamically unstable, constantly reshaping themselves over millions of years as planets migrate, collide, or are ejected into interstellar space. In some systems, habitable conditions may exist briefly, only to vanish before life has time to gain a foothold. By contrast, our solar system has remained unusually stable for more than 4 billion years. Earth has stayed within a narrow habitable zone, neither freezing nor boiling. The Sun has remained remarkably calm for a star of its age and size. The architecture of the system has resisted large-scale disruptions that are common elsewhere. When these factors are considered together, they begin to resemble not chance, but an improbable alignment of conditions. When scientists model planetary formation across the galaxy, systems with this level of long-term stability appear to occupy a small statistical minority. They are not forbidden by the laws of physics, but they are rare enough to stand out, and rare enough to raise a quiet and unsettling question about how often life like ours is truly given the time it needs. The uncomfortable question: if our solar system truly sits on the edge of rarity, then Earth-like worlds may be rare as well, not just in distance, but in possibility. And if planets like Earth are uncommon, then intelligent life may not be something the universe produces easily or often. The idea that the cosmos should be crowded with advanced civilizations begins to feel less like a scientific expectation and more like a hopeful assumption. This does not mean life cannot arise elsewhere. Simple life may be resilient, appearing wherever chemistry allows it. But intelligent technological life is another matter entirely. It depends on a long and fragile sequence of events unfolding in the correct order, without interruption, over billions of years. A single disruption can reset the process completely. A giant planet that migrates too far inward, a star that burns too violently, an orbit that drifts just enough to destabilize climate. Any one of these can erase the conditions needed for observers to ever exist. From this perspective, the universe may be rich in planets, yet silent in intelligence. Worlds may form endlessly, while civilizations appear only rarely, separated not just by space, but by time. Entire species may rise, wonder, and disappear without ever knowing that others briefly shared the same cosmic stage outro. The more we study the universe, the less ordinary our existence appears. What once felt like a random cosmic accident now looks like a narrow path through overwhelming odds. And the deeper we look, the more unsettling the question becomes: are we just rare, or are we alone? This channel exists to explore questions like this, not to offer comforting answers, but to follow the evidence wherever it leads. If you want to understand the universe beyond surface level explanations, and if you're willing to question assumptions humanity has held for centuries, then this is where you belong, because the universe is not just vast, it is selective. Subscribe to continue exploring the universe beyond easy assumptions. And if this idea unsettled you, leave a comment and tell us what you think it means.